Let's get started. So we are getting into the session number 4. So we'll just take a look at what we have done so far briefly and then go to session number 4. Let me show the presentation. So in our course overview, the first session we took a look at applied physics in enabling technology. We took a look at Internet of Things. We just briefly took a look at the 5G communication networks. Now we are getting into the session number 4, which is all about sensors for industrial IoT. Today we'll talk about manufacturing and other industry. And next week we'll cover sensors for industrial IoT smart cities, what type of sensors are used there for automobiles and green energy and so on. Then consumers IoT. Then we talk about communication. If you're interested in speech analysis, don't miss this session number 7. There's a lot of interesting things that are happening there. Our voice is going to be the key. These days, speech technology is getting very advanced. So if you're a physics student who is interested in speech analysis, signal processing, and things like that, there's a lot of opportunity there for you in applying your physics concepts into some solutions, especially in analysis and recognition. And then last one, we'll cover some of the topics. Okay, so let's go to session number 4, where we will talk about the industrial IoT sensors. Okay, so this is sensors for industrial IoT and part 1. Topics, we will first briefly take a look at industrial IoT overview. What is a typical flow that looks like when an industry, let's say a factory or a building, wants to install sensors and implement an IoT solution for themselves. And role of sensors, what are the typical characteristics of the sensors, and what are the type of sensors that are available, right? The temperature, pressure, air quality, and so on. There's so many of these sensors sensing different things. And what are some of their characteristics, right? They need to be real time. I mean, they cannot take a lot of time in sensing, and they cannot take a lot of time in communicating, right? Just like how we do, right? We sense, we see things, we communicate. So our brain operates at a much faster rate in terms of sensing things and then communicating that information, whatever we are sensing, whether it is whatever we are seeing or whatever we are smelling, whatever we are hearing. So something like that, the sensors have to be operating at near real time. Fault tolerant, right? They need to be, they cannot fail. If they fail, then the businesses would lose a lot of money. So fault tolerant is an important. Reliability. How reliable is that data, right? When you say the temperature is 30.2 degrees, how reliable is that data? What is the margin of error? So a lot of that is important. Low power, right? You don't want the sensors to take up a lot of battery power, right? So because you cannot change the battery and the sensors. In fact, some of the sensors, you don't change them for 10 years. So you need to be very low power, low battery life. So if you're a physics student who is focusing more on electricity, more on power, battery technology, then there is a lot of opportunity for you there as well. And in addition to the typical sensor characteristics, we also have industrial IoT, right? Because you could be running them inside a factory, which could be, that means it may be rugged. It's not going to be inside an air conditioner in a home or an office or a campus. It needs to withstand extreme weather conditions, like all these things that I talked about. So we'll cover a lot of these things in this segment, primarily focusing on the industrial Internet of Things. So this is how a typical enterprise this is just a name for business, right? It could be a factory, it could be a building, it could be a company that is trying to install Internet of Things. What are some of the business functions? So they want to make sure that they want to connect their workplace, they want to do it in a smarter way, and they put together a team that says, okay, I want to automate my factory, as an example. So that's all part of business functions. Some of the protocols, this could be a high-level term. This is cellular, that is mobile, which can be Wi-Fi, Bluetooth. Some of the protocols that I talked about, they're all part of that. So basically, you can have several protocol technologies where the sensors can communicate, right? Remember, I talked about the sensors have got two important things. They sense something, then they communicate. They need to tell something that what they sensed, whether it's a temperature, pressure, or whatever it is. So the protocols basically allow the sensors to communicate whatever it sensed. It communicates over the mobile network, or it can communicate over Wi-Fi or Z, Bluetooth. A lot of these technologies are available to communicate to the external world. What are the sensor types, right? They could be sensing light. It could be the HVAC is the air conditioner, heater type of equipment. It could be magnetic sensors, seismic sensors, right? You would have heard about earthquakes and movement of Earth. There are sensors that detect the movement of the Earth. Imaging sensors for cameras, thermal sensors like understanding the temperature, acoustic sensors, something that detects noise, right, around or detects sound. It picks up sound. Chemical sensors that can detect some hazardous chemical material. Humidity is another important one, and then location. In terms of where you are, people use these days GPS to locate where you are. These are all some of the sensors, not all of them. There are hundreds of different things that the sensors are used for. But once the sensors are in place, then two important activities that the enterprises are interested in: how do you measure, and how do you control, right? So basically, the measurement of all of these things that you talk about, once it is understood, then how do you control it, right? So there could be a sensor that says, okay, temperature is going up, but then there should be a sensor that say, okay, shut down that valve, or turn off that switch because we want to shut down the factory. So that's all part of the control. So the measurement and control are two important activities of industrial IoT. In a broader sense, of course, if you go inside the measure, there are so many variations of measure in terms of control. You want a schedule control, you want a human control, you want another machine to control, you want a robotic control. There's so many aspects of control that is involved here. And then what are the domains? Domains is nothing but the areas, whether you want it in retail. For example, it could be a mall that is trying to install an IoT for their mall, and they may want to monitor all the shops inside the mall, how crowded they are. You'll be able to see in your mobile whether a particular store is crowded. If so, you may want to visit that store later on. So there are so many use cases in the retail that you may be interested in. I was listening to a webinar today. Somebody was describing a restaurant use case where the restaurant is fully automated. Basically, it looks at how many. Think of a large restaurant where it can accommodate 100 customers. Depending upon how many customers are in at any given time, all the ovens, the equipment, that the cooking equipment in the back end, they all are connected, and then they automatically turn on, turn off, depending upon how many customers are inside the restaurant. So think of this as if you have 50 customers, and the overall people are interested in particular dish. Let's say those are something, and some of those ovens could be turned on, whereas other things could be turned off. So a lot of automation like this is being talked about in the industrial IoT. So that's one example. Vehicle, we already talked about it. Medical, all of this, logistics, home office. These are all different domains where the industrial IoT is becoming more important. So I hope this gives you an idea of how, when somebody implements an IoT in an enterprise, these are the things that one need to worry about. What protocol should I use? Should I get all my sensors using Bluetooth? Should I get some sensors in Bluetooth, some sensors in Wi-Fi, some in Zigbee, some in cellular? How do I do it? And then what are the things that I'm sensing? What do I need to measure? And how do I need to measure? How do I control it? And then depending upon which domain you are in. A lot of the times, there are many companies who do this for enterprises. The enterprises themselves, for example, if you are a multi-story apartment building, the apartment building owner may not know exactly how to implement a lot of them, but they go to other technology companies and say, I want to automate my building. and I want to monitor this. These are my requirements. Then the technology company goes, maybe it could be Cognizant, it could be Infosys, Wipro. Some of these companies can go and put together the solution. They will go suggest to the apartment building, okay, these are the sensors that you need. This is where we're going to be keeping them, and this is where we're going to be controlling them. And by the way, here is the app for your phone. You can control them from your phone. So a lot of people need to get involved in completing an industrial IoT. And depending upon which domain you are in, the number of people and the type of sensors and the type of control and measurement that you're looking for will vary, right? I think the other thing that I also heard was shoplifting, right? In malls, there are so many, because of this pandemic, many shops have started doing self-checkout, right? So you buy things, you put them in your shopping cart, you go through the self-checkout, you scan the item that you purchased, and then you walk away. So the system needs to make sure that you did not miss anything unscanned, right? So those are some other things. I've also heard where people can take the barcode from a cheaper product, put it onto an expensive product, and then start doing some fraud. How do you prevent fraud? And these things have to happen very quickly, right? The customer is going to go through the self-checkout. You need to catch all those things very quickly. This is why the Internet of Things is important. And you need to catch it in the store. So this is where the edge computing becomes important. You need to quickly realize that the customer is trying to cheat, and they need to catch right away and things like that. So a lot of real business challenges and applications for Internet of Things and edge computing. So you will hear many such use cases where sensors are going to be playing a very important role in the industry. Okay, so that's on that. Let's take a look at some of the sensors, right? So if you take a look at role of sensors in IoT, I think we touched upon some of them. Let's just go through some of them. For example, chemical gas, carbon monoxide poisoning is a very common problem in Western countries because a lot of the times in the winter time, we all use heaters, and heaters generate unwanted gas, and carbon monoxide could be a deadly thing for everybody. So there are carbon monoxide sensors at home. So these are so that's another sensor that basically senses gas. Then the second one is acoustic sound vibration. This is, I talked about. It could be as simple as a baby trying to wake up in the middle of the night, and then you want to pick up that sound, and then send it to parents saying that your baby is awake. So there are many cases, even in hospitals. Patients they have some issues, and there could be acoustic sensor that could be sensing that in addition to camera. Humidity and moisture. This is an interesting one. I mean, some of the cars, for example, BMW, some of the models have this sensor where it automatically turns on the wiper when it starts raining, right? So as soon as the windshield detects moisture on it, then it triggers the wiper, and then the wiper goes on. And depending upon how fast the rain is coming, right? How fast the moisture content on the glass is going to be, the speed of the wiper changes. So this is another example of humidity moisture use case in the cars. Of course, there are many other use cases as well. You may want to make sure that you have a patient who is very sensitive to environment. In the hospital, you want to make sure that the humidity is contained because there are humidifiers in the hospital rooms. So this is the humidity sensor that basically says, oh, it is now too humid or too low humid. So you need to adjust that accordingly. So this is a very important sensor as well. Temperature, we all know. AC is a classic example. All of our air conditioner equipment, they have temperature sensors. Motion, velocity. I think this is, for example, speed of a fan, right? Let's say, again, in the health scenario, you want to make sure that all the fans are operating at the right speed. So something could be looking at the velocity of the fan. and position is same thing. A lot of things about machine camera, optical, ambient light. So a lot of optical sensors are available today for many of these. Acceleration, tilting. So I think the classic example is a gyroscope and things like that. And on our mobile phones, when you tilt the phone, something happens. So there are sensors available for that. Typical things, electrical, magnetic, you probably are aware of a lot of the stuff. And the leak levels, I think we talked about that in the previous class. You can take a look at a particular water level, whether it's in a tank or in a boiler or in a plant. You want to detect those levels. There are sensors for that. And then, of course, the pressure sensors and flow sensors and so on. So this gives you an idea that there are so many types of sensors, and each one of them has got zillions of use cases. Many places where they are used. How that is used, depending upon the environment. But fundamentally, as scientists, you should be looking at which one of this is interesting to me. Which one of this would I like to try out? And then there are small sensors that I showed you in the previous in that site. You can go buy them. You can go buy a kit that does, for example, temperature sensor or a humidity sensor. You can start experimenting with them and then try to understand how it is sensing the temperature. What is exactly the technology? What is the material that is used in sensing the temperature, and how does it do? So I think depending upon your area of interest, there's plenty of options available, whether it is for light, sound, temperature, force, chemical, anything, right? That you have get to consider. But all of them are important because they are all used in one way or the other in some industry. So what I would like to point out is there's no such thing as this is more important than the other one is. Every sensor is important because they are used in industry to either save money, to save time or save lives, to improve quality of life, to save the planet, to conserve water, to conserve energy, you name it, right? They play a very vital role in making the world a better place to live. So I think you can do offline, take a look at any one of them that is of interest to you, and then zoom in more and then get an idea of what you want to do. I think the purpose of our course is to inspire you, the reasons why sensors are important, and so that way you get motivated and then focus on some of the sensors and do something with them. So that's on that. Here is some example sensors. This may not be too easy to read. I just taken it from some websites. These are very small temperature sensors, pressure sensors, and so on. Nothing more exciting. Here is another magnetic field sensor. So your lab might have some of them already, or you could go buy them, but nothing more interesting here than that. Just an example sensor. And I think we talked about it. The key characteristics I want to repeat again. The sensors, we need to make sure that they are real time, like some of the use cases that we saw. You just don't have the time to take a lot of time to sense it. So both sensing time as well as the communication time, both are important. There's no point in sensing very quickly but taking a lot of time to communicate. Even that is not useful. This is why if you go back to the protocols, the protocols play a major role in how quickly whatever the information that the sensor sensed can be shared with the others. Some protocols will take more. Some protocols are heavy. That means it takes more time. For example, Wi-Fi is a very heavy protocol. That means it takes more time to send information over Wi-Fi as opposed to NFC. NFC, you might have seen the touch payment, right? You know, let's say if you have a credit card or a debit card, you go through an enterprise. You used to swipe the card to make the payment. Nowadays, you just touch, right? The touch cards, they're all based upon NFC. This is called near field communication. So the protocol that is used in communicating whatever the sensor has sensed is also equally important, because you want to communicate very quickly. You don't want to have very thick protocol like Wi-Fi, but sometimes Wi-Fi is needed, because some protocols may not be enough to send the information. For example, if you have a camera, you want to send a video stream, NFC is not going to work, Bluetooth is not going to work, Z-Wave is not going to work, only Wi-Fi is going to work. So it really depends on what you're trying to sense here, and how quickly you want to send that information, how quickly you want to communicate that information to the external world. This is why you have a variety of protocols. So I think I go back to the characteristics. So it's important that you sense very quickly, you communicate very quickly. Fault tolerant, I think, like I mentioned, a lot of them are mission critical applications. They cannot fail. There are instances where this is hardware, right? It is bound to fail. So they'll have redundant sensors. So let's say if you are sensing for carbon monoxide poisoning, you don't want to rely on only one sensor. You may have 3 sensors. So even if one of them fails, the other 2 will detect the gas. Likewise, humidity. You take any one of these sensors. Typically, they're equipped with multi sensors. So it's just not one sensor. So you don't rely on only one, because it's in the end of the day, it is all hardware. They are bound to fail, like any other equipment. So in order to have a fully fault tolerant system, what the companies do is they create an array of sensors, because they are not that expensive. So it is okay to put 2 or 3 of the same sensors, and then they have a way of determining which sensor is working, which sensor is not working. So fault tolerant is very important. Reliability, I think we touched upon it. How reliable is the data, right? When we say that it is telling us that there is carbon monoxide, the gas, how are we sure? What is the level in which that it has triggered that alarm? So how reliable it is? What is the error rate in those sensors? So reliability is important. Low power, long battery life, these two go together. I mean, we have seen, the automated doorbells. In fact, even some of the cars these days, right? You have key fobs. You have battery operated key fobs to open the door and close the door. Those key fobs, they have a very small battery, and you don't change them for a number of months, if not years. So it is very important to have these sensors to consume as slow electricity as possible, as low power as possible. So that way they can have very long battery life. So that is an important aspect of the sensor. And then now we are talking about industrial IoT. You would have seen that they need to be rugged. They cannot be very fragile. That when the temperature goes over 35 degrees, it should not melt. So it should be able to withstand very extreme weather conditions, whether it is very hot or cold. We all know that every state, every city has got different weather conditions. Some places are more polluted than the other. If you go up north, it is a little bit colder, much colder in some places. So it's very important to make sure that the sensors are designed for a variety of weather conditions. So that adds to the complexity of sensor design. So as Adam talked about, what are some of the research areas? People in the sensor design, sensor research, these are always things that they consider. How do I design a temperature sensor that can run at very high humidity, very high, very hot temperature, completely polluted? I can still sense the temperature properly. So I think those are all challenges that scientists always face. So they work with the scientists in that case, work with the material science people, the chemist in the department, and then they come up with a joint solution and say, yeah, this is how we should assemble the sensor. This is how we should build the sensor, such a way we can read that criteria. So there's a lot of research that happens in making sure that the sensors are reliable, they are available, they can withstand all these tough conditions. and they are extremely reliable in sensing things, and they're extremely fast in communicating things. So you can imagine the sensors technology is very, very complex. Though it's we all take it for granted, right? When we see our AC in our hall sensor the temperature is 35, senses the temperature is 19 degrees Celsius. We take it for granted, but there's a lot of work that has gotten in and to make sure that the sensor is working fine. So I hope that gives you a good perspective of the importance of sensors and the challenges that the scientists and engineers face in building reliable, available, tough, and high-performing sensors. This time I would like to just to show a brief demo. This is very glad to announce that we have a student, Radesh Sharma. He's a second-year BTech student from Computer Science and Engineering from our college. And so he built a solution of communicating a simulated temperature module to a Facebook Messenger chatbot. So this time I will play this video. Let me see if I can stop sharing and then go to that and play that video. I hope that gives you an idea of what are the real use cases of an IoT sensor that the student has built. But of course, it comes from the computer science and engineering background. He did not build the hardware; he did everything in software. But it'll be great if he could get a hardware, then he can make things work with the real hardware as well. So let me play that video shortly. Let me see how I can do that. Google Meet. It's always a challenge to play a video from the same. Let me see if we can do that. I think I should do a tab and share audio. Correct. Okay, so this is the video. It's a short 3 minutes video. So the initial part of it, you'll be able to get a good idea that basically we are trying to connect an IoT to a human. The human is using the Facebook chatbot, Facebook Messenger app on the PC, and he'll be getting the temperature, pressure, and the humidity and so on from a simulated sensor. And then after that, he explains how he has done and stuff like that. That may be a little bit out of context, but it's still a good idea for you to listen to it. Let me see if I can set the quality correctly. Quality is 720p. That's good.
Hello, this is Radesh Sharma. In this video, I'm going to show you a demo of our IoT Edge project, which basically transfer the data from one device, which is IoT Edge device, to any another device which is using the Facebook chatbot. So as we are using the Facebook chatbot, so let me start the conversation with hello message. So as I send the hello message, it reply with me, how may I help you? So let me ask for the temperature. As you can see, I got the temperature value. Now let me ask for the pressure. So it reply with me the pressure value. Let me ask for the ambient temperature. So this is our ambient temperature. At last, let me ask for the time at which this data is collected. So you can see this data is collecting live at the time. So how does this everything is working? Let me show you. This is our Facebook chat, which is controlled through developer.facebook.com, where we have integrated one webhook, which is published using ngrok, as you can see here. So ngrok is redirected at our localhost 3000, and at localhost 3000, we are running a Facebook chatbot script. Now let me show you a simple Facebook chatbot script. We have a very simple script for the Facebook chatbot, which is retrieving the data from external storage space and sending that data directly to the Facebook user. Now let me go toward the external storage space. So this is our external storage space where we are storing the data. We are collecting this data from our IoT Edge device. We are running a simple script in our IoT Edge device, which is sending the data to this external storage service from where we can retrieve our data at any time. at a live position. So we are subscribing one topic of MQTT from where we are collecting data and sending that data to the external storage. As you can see where I am sending, wait, this is where I am sending the data to the external storage space. Now let me show you from where this data is collecting. As you can see, this is MQTT Explorer where all the data is coming up, which we are getting from the IoT Edge custom module. Our IoT Edge custom module is running inside this virtual machine, which is our IoT Edge device. That IoT Edge custom module is collecting the data from temperature sensor or another sensors and then sending that all the data to our MQTT broker. Now let me come toward our IoT Edge custom module code. Here we have some files of the IoT Edge custom module, and the main file of this custom module is app.js. In this file, first of all, we are requiring some few main things, and like we are connecting with MQTT. So we are defining the port for MQTT, which is 1883, and we are also setting a threshold value of 25. So we are filtering the messages like the temperature should be only more than 25, and we are consoling some few logs so we can be updated with the things. Here we are sending all the data to the MQTT broker at topic edge device slash sensor slash temperature. So this is all about how our this complete project is working on. Hope you will get this helpful. Thank you.
Hope that gave you an idea that what the students have done. They've connected a simulated temperature sensor to an edge device, and then they communicate it to a human who is using a Facebook Messenger application. So this is the typical use case where a temperature sensor is saying that, hey, there is something is boiling and something is not right. That information can be transmitted to a human being who is sitting on a messenger. So this is one of the examples of what he has done. So that gave you an idea of what we are trying to do. Now the students are now trying to get a real sensor, real temperature sensor, real pressure sensor, humidity sensor, air quality sensor in the IoT lab, so we can do exactly the same. It's no longer simulated; it is actually sensing the temperature inside the lab. And then we can also do projects like we can have a camera. You can count number of students in the lab. So things like that are simple projects that one can do to show how sensors are helpful in the IoT space. Okay, so I think that is all. Let me go back to my presentation. If I had anything else, let me just briefly go to that. Yeah, I think that was my last slide. So just to summarize what we did in the fourth session, we took a look at industrial IoT and the role of sensors. We took a look at all types of sensors. We got motivated from different type of things that it is sensing, and we looked at some key characteristics, especially how quickly it can sense and how quickly it can communicate, and then some of the IoT requirements for the industrial point of view. So with that, let me pause here, see if you have any questions or comments or feedback. Yeah, the floor is yours. Please ask any questions on whatever we have covered in all the four sessions. It doesn't matter. It has to be the fourth session. It can be any session. No questions? I thought there'll be more questions as we go into more sessions. You can also use the chat window to ask questions if you have.
Sir, are we completed, sir?
Yes, I think we are done with the sessions, madam.
Okay, I will put the attendance link.
Sure, madam.
Students, please wait. I will put the attendance link. Please fill the attendance. Once you have filled, you can leave. So thank you for attending. Thank you, sir.
Thank you, madam. Thank you all.
So regarding the next week timings, I will confirm with you, sir.
Thank you, madam. We'll do that.
We have four sessions left. We'll try to complete by next week. Otherwise, we'll have one hour and we will complete it the week next, sir.
Sure, madam. No problem at all. Please do it. What works.
Thank you, sir.
Thank you. Thank you, madam. Thank you all students. Have a good day. We'll sign off now.
Thank you.